This will be a two-part series. In this first part we will discuss about current air defense system around the world and how laser air defense system works and its advantages and disadvantages. Israel has Iron Beam laser weapon system that reportedly has the capability of intercepting rockets, mortars and anti-tank missiles. Called a game changer, it is claimed to be the world's first energy-based missile defense system that employs a laser beam to strike down incoming attacks. It was unveiled at the Singapore Air Show on February 11, 2014 by Rafael Advanced Defense Systems, with the final field tests taking place in May 2022. Iron Beam is likely to be fielded by 2023 and will form part of Israel's multi-layered air defense system that presently comprises of the Iron Dome, David's Sling and Arrow systems. Even as the Iron Beam awaits full operationalization, Russia announced that it has already deployed Zadira, an advanced laser weapons system in combat in Ukraine. Reacting to these claims, the US Department of Defense issued a statement that there was no evidence to corroborate reports of lasers being used in Ukraine. Zadira is the second Russian laser weapon system, the first being Pereshwait, which can be used to dazzle satellites orbiting high above Earth and prevent them from gathering information. While the war of words may continue over the capabilities and fielding of Zadira, there is no doubt that there is an urgent need to operationalize laser air defense weapons at the earliest to counter the emergent air threats in a more efficient manner. The need to develop laser air defense systems becomes apparent when the limitations of existing air defense systems are considered. The air defense weapon systems have evolved over time and are capable of taking on most of the air threats, but these systems have certain inherent limitations which makes them either not capable of countering some of the threats or the engagements are not cost effective. These limitations are more obvious in case of countering the threats at the two extremes: the high-speed targets, missiles and hypersonics, at one end, and low-cost aerial threats like drones on the other extreme. The limitations of majority of air defense systems in countering missiles and hypersonics due to the high-speed, multi-Mach speeds, and very low reaction time are well documented. The use of Scud missiles by Iraq during the Gulf War was one such example when the Patriot missile system failed to effectively counter them. United States Army admitted that a re-evaluation found that Patriot systems destroyed, damaged, or knocked off course more than 70% of the Scuds that came within range in Saudi Arabia and more than 40% of those that came within range in Israel. A successful engagement by Patriot should have been if the Patriot destroyed or damaged the warhead, caused a partial burn of warhead, or knocked the Scud body off course, but these parameters were tweaked by the US Army and it declared Patriot to be a success even if it destroyed or damaged the warhead, caused a partial burn of warhead, or knocked the Scud body off course. A similar failure was experienced in Saudi Arabia when the Patriots failed to counter the missiles fired by the Houthi rebels. Patriot is not the only system with such limitations. Taking the case of Iron Dome, the frontline Israeli air defense system. It is one of the most advanced air defense systems in service today and is regularly used to counter the frequent rocket and mortar attacks against Israel. According to claims made by the Israeli defense officials, Iron Dome has a 90% hit success rate. However, these figures of 90% success rate are not supported by any evidence. Also, Iron Dome has proved itself to be ineffective shorter-range rockets and mortar attacks launched from nearby Gaza, which resulted in Israel looking at alternate defenses to augment the system. In a similar manner, at least 23 Pantsir systems were destroyed by Turkish Bayraktar and Anchor drones in Syria and Libya in 2020 alone, despite the fact the systems were expressly designed to counter these low and slow-flying threats. In the ongoing conflict in Ukraine, Ukrainian drones remain effective despite the presence of strong Russian electronic warfare capabilities and air defense systems, with an older Buk launcher destroyed by a Ukrainian Bayraktar drone. As the cost factor is also an important consideration in evaluating the efficiency of a system, most modern air defense systems are not suitable for use in countering low-end threats like drones and improvised aerial platforms, including improvised missiles and rockets. A drone bought off the shelf improvised to carry explosives would cost only a couple $100, and it makes no economic sense in expending a high-tech air defense missile costing tens of $1,000s to shoot it down. And if the drones and rockets are fired in tens and hundreds over weeks, there is a need for more efficient air defense systems to counter them. Air defense guns are an option, and the close-in weapons systems of CIWS, like the Gatling-based Phalanx, are one of the gun systems as service, but they also suffer from inherent limitations in terms of target handling capability and maximum effective range. It is only about 1.4 kilometers. The ammunition expenditure is another factor needing consideration, as a mount or a gun can carry only a specific amount of ammunition, and that restricts the number of engagements the gun can carry out before it needs to be rearmed. One of the methods to address the challenges of engaging and shooting down aerial targets in a cost-effective manner in an effective way is by using directed energy weapons, or DAW, including the lasers, which are now maturing as a viable alternate to traditional air defense systems. The first laser was built in 1960 by Theodore H. Maiman at Hughes Research Laboratories, based on theoretical work by Charles Hart Towns and Arthur Leonard Shollo. It differs from ordinary light as it is monochromatic, coherent and directional. It contains one specific wavelength of light, one specific color. The wavelength of light is determined by the amount of energy released when the electron drops to a lower orbit. It is organized, each photon moves in step with the others. This means that all of the photons have wave fronts that launch in unison. And being highly directional, it has a very tight beam and is very strong and concentrated. These characteristics make lasers suitable for use as air defense weapons with the capability of shooting down bullets with bullets, something that all air defense systems aim to do. Laser weapons have several advantages over conventional munitions. They transmit lethal force at the speed of light, traveling at about 300,000 km per second. That gives them the capability to engage distant high-speed targets immediately after detection with very short reaction time. A laser has a near perfectly straight trajectory, unlike the arc of an artillery round, as their beams are not affected by the constraining effects of gravity or atmospheric drag, which allows the laser to be much more accurate in finding its targets. They are extremely precise, enabling low-profile and covert operations capabilities with less collateral damage. Their effects can be tailored by varying the type and intensity of energy delivered against targets. Lasers are silent and invisible to the human eye and are thus hard to detect by the enemy. Laser beam can also be scaled to the object in question, and the power of the beam can be adjusted for different material. Accordingly, it can even have a non-lethal adjustment if required. Though the initial installation costs are high, but after deployment, laser weapons provide cost-effective engagements. And unlike a traditional gun, lasers don't run out of bullets. Lasers have their downside too, as they take a lot of energy and have difficulty penetrating haze, dust, smoke and materials with anti-laser coatings. The drawbacks notwithstanding, lasers have the potential to be a low-cost, effective complement to kinetic energy, and have the potential to be more effective at addressing rocket, artillery, mortar, or ram threats, as well as unmanned aircraft systems and cruise missiles. Thank you for watching. Like and subscribe.